Cardiac muscle, sections 4 and 5. So compared to skeletal muscle fibers, smooth muscle fibers are much shorter. They have one nucleus located near the center. They are elongated with tapering ends. Their myofilaments are more randomly organized, so we don't get striations. They don't have transverse tubules, and they don't have the sarcoplasmic reticulum, at least not to the same extent as skeletal muscle. Smooth muscle can either be a multi-unit smooth muscle or a visceral smooth muscle. Multi-unit smooth muscles the cells are less organized. They function as separate units. Their fibers function independently. We find these in the iris of the eye and the wall of blood vessels. They are under the control of neurons and hormones. The visceral smooth muscles are single unit smooth muscles. Their cells are going to respond as a unit. They're sheets of spindle shape muscle fibers. Their fibers are held together by gap junctions. They have rhythmicity, so they beat with a rhythm. They are very important for the conduction of peristalsis, especially in the digestive system. And most of the hollow organs have smooth muscle in their walls, and this visceral smooth muscle is the most common of the smooth muscle types. A smooth muscle contraction looks a lot like skeletal muscle contraction in the fact that there's an interaction between the actin and myosin. Both are going to use calcium and ATP, and both are triggered by membrane impulses. However, they are quite different at a physiological level. Smooth muscle doesn't have troponin. It uses another protein called calmodulin. The neurotransmitters that affect smooth muscle can be acetylcholine, but can also be norepinephrine, and the response of acetylcholine will depend on the type of receptor it has, so it will not always be a stimulatory response. Hormones can then therefore stimulate to inhibit or stimulate smooth muscle. Stretching can also cause smooth muscle to contract. Smooth muscle contraction is slower, and they are more resistant to fatigue. Smooth muscles change length without changing their tightness. Cardiac muscle, located only in the heart. They are striated muscle cells, very similar to skeletal muscle because of the way the actin and myosin is organized. The muscle fibers are joined together by intercalated discs. Their fibers have branches in them, but they contain a single nucleus. They act as a single unit. It's called a syncytium, so that the heart will beat as one unit, not as a group of individual cells. It is self-exciting. As I said, it has its own nervous system, and it contracts as a unit. Sorry, I did that already. It's rhythmic. It contracts with a very specific rhythm, starting from the pointy end at the bottom of the heart, moving upward. There's a longer refractory period than skeletal muscles for cardiac muscle, and you cannot get sustained or tectonic contractions in cardiac muscle like we did in skeletal muscle. So if we take a look at all three of these, if we look at the dimensions, skeletal muscles are up to 30 centimeters, whereas smooth and cardiac are in the range of microns. Skeletal muscle is skeletal muscle, walls of hollow organs for smooth, walls of the heart. The function is a movement of bones at joints, movement of walls of hollow organs in smooth, and cardiac is pumping blood. Striations are present in both skeletal and cardiac, but not in smooth. And both smooth and cardiac are involuntary, and skeletal muscle is voluntary. Okay, there's another couple sections.